Hello, welcome to my video on Math Made Easy with Terry in 10 minutes, okay? In the previous video, I gave you the 5 steps, okay, to solving function of a linear function of x, okay? And I gave you the 5 steps, okay? And the previous video, I told you to take a screenshot or write it down in your notebook, and we're gonna solve some questions with that, okay? So now, let's do this, all right? Let's solve this. I promise to solve this question, 2x minus 7 raised to the power of 3. So what do? Remember the first step. So the first step I told you was that you have to replace the linear function with a letter, okay? And add the x over dq dot dq. So for instance, I'm going to say, let the linear function, so let 2x minus 7 to be equal to what? Q. So I've replaced the linear function with a letter. So I'm going to write it now. So it's going to be, all this is going to become q raised to the power of 3. And remember I said you then add the x, because it's q now, over dq dot dq. So you can see that this, the q and dq will cancel out and still give me back the dx. So technically I didn't do anything, all right? Now, when you're done with that, you keep that separately now, all right? So keep this. We've done the replacement here. Now let's go to the second step. Now the second step, I told you that the next thing you need to do is to what? Differentiate the linear function separately and find the x over dq. So the linear function we have is q is equal to 2x minus 7. So differentiate it. So that means the q over dx is going to be 2. But remember what I said, we are not looking for dq over dx. We are looking for what? Dx over dq. So that, therefore, you cross multiply, okay? So that means dq, or let's put it this way. So dq over dx is equal to 2. So therefore, dx over dq, dq will be equal to 1 over 2. Can you see? So remember, if you swap this, you're going to swap this as well. So that means dq over dx. We're not looking for dq over dx. We're looking for dx over dq. So dx over dq is going to be equal to 1 over 2. Done. We're done with what? The second one. Now, what's the rule 3? If you go back to the rule I gave you, the third step is that what do you need to do? You need to replace the variables to the equation. Okay? Very good. So now we know this. This is the equation here. Okay? So we know we're integrating q dot dx over dq is this one here, is what? 1 over 2 dot dq. Then when you replaced it, what's the next step to do? I told you that you need to integrate as normal. Is that okay? So how do you integrate? So remember, when you're integrating, you bring out the constant. So it's going to be 1 over 2. We're integrating q3 dot dq. And remember, how do you integrate the q3? It'll be 1 over 2. So it's going to be q3 plus 1 divided by what? 3 plus 1 dq. Can you see? And that will give you 1 over 2 multiplied by q raised to the power 4 divided by 4 dq. So I can open the bracket now, and that will give me q raised to the power 4 divided, this is going to be plus c. I made a mistake here. After integrating, the q turns to plus c. Is that okay? Okay, plus c. It will be the q raised to the power 8 plus what? C. Then the fifth step. Remember the fifth step? I now said replace the letter with the linear function. So the letter we have here is q, and we know q is what? 2x minus 7 raised to the power 4 divided by 8 plus c. And this is the answer we are looking for. So when you integrate 2x minus 7 cubed dx, the answer you will get is what? 2x minus 7 raised to the power 4 divided by 8 plus c. Okay? Let me solve one more, and let's see if we can play around with it. Okay? So let me just add maybe like a a trick now this time, okay? Same thing. So we have number 2. Let's say we're integrating cos 7x plus 2 dx, okay? Similarly, because normally it should have been something like we're integrating cos x. Does that make sense? Oh, sorry, we're integrating cos x. Does that make sense? So that means now x have been replaced with a linear function 7x plus 2. So that means we have to use the same principle we talked about. So, same thing. Number 1, the first rule is replace the linear function with a letter. So that means I'm going to let q to be equal to 7x plus 2. Can you see? Then the next thing, I'm going to add the x over the q to it. So that means it's going to become, I'm now integrating cos q dx over dq, okay, dq. Does that make sense? This is it. Okay, this is dq. I don't know if it's clear there. Now, what's the second step? We don't stop there. The second step now, we then differentiate the linear function separately. This is the linear function, right? You have to differentiate it now. So q is equal to 7x plus 2. So dq over dx is going to be equal to what? 7. But remember, we are not finding dq over dx. Remember, from the second step, we're finding dx over what? dq. So dx over dq, so that means you just flip it, okay? If dq over dx is 7, so if you flip it, it's going to give you what? 1 over what? 7. Now, what's the third step? The third step then is that we then have to what? Replace all the variables back to the equation. So we know this, so we're integrating. This is cos q, so that means we have cos q dot dx over dq is now 1 over 7 dot dq. Now the fourth step, okay? We're done with that. We then have to what? Integrate and add c, okay? So let's go. So we're integrating cos q 1 over 7 dq. You bring out the constant, so you have 1 over 7. You integrate cos q dq, okay? So it's going to be 1 over 7. When you integrate cos q, so remember we talked about sine, cosine, minus cosine, okay? So when you integrate cos, what do you think it should give you? So remember, when you go clockwise, is differentiation. When you go anti-clockwise, is integration. So when you integrate, cos is going to give you what? Sine. So that means it's going to give me what? Sine q plus c. Okay? So that means you multiply, it's going to give you sine q over 7 plus c. Then the fifth step said that you have to then replace the letter with the linear function. So we know q to be what? 7x plus 2. So that's going to give you sine 7x plus 2 divided by what? 7 plus c. And that is the answer you're expecting for this. All right. And that will bring us to the end of this session, okay? So please remind yourself, go back to the previous video I had. I gave you the 5 steps. So the first thing you do, you replace the linear function with a letter. You can choose any letter. In this video, I'm just using Q. A doesn't matter. Then you now put it, you now replace add dx over dq to it, okay? So you now differentiate it, then you now find the x over dq. So that means when you differentiate it, it's going to be dq over dx. But after you're done, you just flip it to give it dx over dq. You put it back there, you integrate as normal, and you add what? C. And this will bring us to the end for this. I'm going to solve 2 more questions in the next video. I'm going to solve how to integrate a linear function with exponentials and also with fractions. So that's the next 2 videos I'm going to talk about. Okay, so please don't forget to like, share, and if you have any question, put it in the comment, and I'm going to try to respond to that. Okay, so I'm going to see you soon. I'll see you in the next video. We'll talk about integrating exponentials and fractions. Okay, So see you soon.